So hi guys, how are you people doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, and here all the concepts of physics, chemistry, and maths are being taught to you completely in English. Unacademy has already become one of the largest online platforms for IIT JEE studies, and here we are trying to give you studies a boost, not only for the IIT JEE exam but even for the Olympiads. Okay, so this is the series that I host for students who are aiming to crack Olympiads or even aiming for some top ranks in the advance. Okay, so as you guys know, right now in the market, there's this book which is considered to be one of the toughest books in physics right now. Okay, so this is the Pathfinder Olympiad and other advanced level problems in physics book. So this is a series where we discuss questions from that book, and let's see. And I help you to develop an approach where you can figure out how to approach and solve these really complex problems. All right, so before we get started with today's session, let me introduce myself for those of you who might not know me yet. Okay, so my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi, and I've been teaching physics for the JEE Mains, Advanced, and Olympiads for almost 8 years now. So I myself was all India rank 447 and all India rank 192 in the two stages of the ITJ exams that I took. I also qualified NTSC Stage 2 as a student, and I was also in the top 1% of the NSCP, which, as you know, is the National Standard Examination of Physics or the first stage of Physics Olympiad. I myself have coached many students to top ranks in JEE Advanced and Mains and in Olympiads. So let's hope that I can continue doing that with you guys here. So again, the Unacademy is bringing you the opportunity to study from the best teachers and get great results in all your exams, even in this lockdown period. So how you can achieve that is get yourselves the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators on a regular basis as if you were continuing your studies in the offline setups. Okay. You also have live polls and leaderboards in these classrooms, which keep them highly interactive. Next, you have test series and analysis sessions which help you keep you on your toes and keep you aware of your standing in the competition. And finally, you have live doubt clearing sessions. So this is another important aspect of all Unacademy Plus courses. So every fourth session in your Unacademy Plus courses is supposed to be a live doubt clearing session. So along with these benefits, Unacademy is also providing you the opportunity to study from the topmost teachers of India. Hello, family home. How are you? Hello, AP. Hi, Rajesh. How are you guys doing? So as I was saying, along with all these benefits, Unacademy is also providing you the opportunity to study from the topmost educators of India from the comfort and safety of your home. So now you sitting in one town can study from the topmost teachers all across India from with the help of this Unacademy subscription. So this is a list of courses which are ongoing on Plus, which are being taken by the JEE English team. So if you follow JEE English, you can get yourself the subscription and enroll in these courses. So 3 courses for class 11 topics, which include an advanced course on mechanics, which I am taking, and then you have 4 more courses for class 12 topics, which include an advanced course in electromagnetism that I am taking. All right. So how do you enroll in these courses? How do you get the benefits of the Unacademy subscription? Very easy. First, you need to install the Unacademy app. Once you do that, you go to the apps plus section. You select your goal as ITJ and you click on that get subscription button. Now, when you do that, you will be redirected to the payment page where you will realize that the payment fees have been kept very affordable. And this is a look at that. This is what the payment page looks like. So you will realize that the fees of various subscriptions is very competitive compared to the fees that you might have to pay at any of the offline coaching institutes. And here with this subscription, not only are you ready to prepare for your JEE Advanced, JEE Mains, Olympiads, any kind of preparation that you feel like you can go for that with these subscriptions. All right, these subscriptions will become even cheaper if you use this code. You can use the code RD Live, and this will give you a 10% off on your subscription fees. All right, family home. Good to know. Then all you need to do is click on this proceed to pay button. That's about it. And the moment you do that, you get yourself the subscription. Now, Unacademy is also providing you an opportunity to get the iconic subscription. So this is something that Unacademy started recently. So there is another thing called an iconic subscription, which will take your JEE preparation to the next level. So here you have personal coaches available for you. So you get a very personalized guidance, a complete track of your performance, and constant feedbacks You have ITJ workshops, you have expert guidelines, you even have a study planner, which I think most of the students struggle with. People don't know how to manage their studies, right? So here, An Academy team will help you make a study planner, and you will have constant test analysis sessions again. So constant feedback, constant monitoring on a very personal level, which will ensure that you propel to those top ranks that you aim for. Now, please note that the subscription fees for the iconic subscriptions is going to get hiked from 30th of November. So after 30th of November, the 6-month iconic subscription will cost 38,000. The 12-month iconic subscription would cost 65,000, and the 24-month iconic subscription would cost 1 lakh rupees. All right. So if you're planning to get yourselves the iconic subscription, hurry up, get it before this date, 30th of November. So get it before 30th of November. All right. So, okay, Lokesh says, sir, sir, today Narendra Modi came to our state Telangana. Okay, I didn't know this. All right. So, how was it? Okay, another surprise for you guys. So, An Academy JEE English team is going to bring you an Ask Us Anything session. So, wherein it will be a highly interactive session with all your teachers or the entire team of JEE English. And this will happen, I think most likely to happen on 2nd of December, if I'm correct. So 2nd December, I think, will be when this session will be happening. So you can interact with your favorite educators of the JEE English team and ask them any questions. So this will be a fun interactive session that we guys hope to have with you. Okay. All right, Lokesh. Great. Did you go and see him then? Okay. So I live in Delhi, so the PM is here most of the time. So so yeah. So I can imagine your excitement though. All right. Again, hi, Devra, Varun, how are you? Again, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. Do that so that you're not missing out on any of the lectures and sessions that are happening on the JEE English channel. All right, no problem. All right, so as I had said, this is the third topic that we are taking up in this series. We've already discussed a lot of problems from Newton's laws. Then we discussed problems from work, energy, and power. And today we're going to talk about Olympiad and advanced level problems from momentum and a center of mass. Let's get started with the discussion. So this is the first problem that I have for you today. So this problem tells you a block of mass 2 kg is sliding on a frictionless horizontal floor with a velocity of 5 meter per second due east. It is subjected to a variable net force for 10 seconds, resulting in an impulse of 6 Newton in the north direction and 18 Newton in the west direction. Okay, you have to find the total work done by this force. Okay, so good luck with this problem. This is a relatively simpler problem, but I wanted to start with a relatively simpler problem, which you guys should be able to solve and feel good about it. Okay, so this is one of the simpler problems that I found in this book. Hi Raj, see how are you? So try this and let's see how many of you can get this correct. Okay, this is another interesting problem which I want all of you to try. Okay, let's see how many of you can figure this out. Yes, please do. That is what this session is for. I want you guys to try it first, and then we can have a discussion about the problems that you guys can't figure out. And the idea is through discussion, I will help you develop an approach of how to, tackle these complex problems. All right, AP is also trying. Great. So you guys can try it. Till then, I'll help myself with some water, and let's see if you can figure this out. So again, this I said, this series is tackling some of the toughest problems that are there in physics right now. At least I think this book is one of the toughest books available in the market. So this session is aimed to not only get you some practice, also stimulate your brain, challenge you to find some. Okay, so zero. Yes, that is in fact the correct answer. Very well done, guys. All right, great. Yes, 0 joules is the correct answer. So I am glad that a lot of you were able to solve this. Very well done. All right, so this is a relatively simple problem. I expected a lot of people to give this answer this correctly, so which is nice to see. Let's see how you would have solved this. So you have been told that 2 kg block is has a velocity of 5 meter per second in the east direction. Okay, so let's draw ourselves that situation. So this is the initial condition. All right. So this is the east direction. Okay, assuming these to be my y and the x axis. Can I say the initial momentum? Initial momentum is 10 I cap. Right. Initial momentum is 10 I cap. How about the impulses? Impulse vector has been told to me as 5 due 6 due north and 18 due west. So impulses that act on this would be this direction 6 and in this direction 18. So this is the impulses that it receives. This will be Iy, this will be Ix. Correct. So what is the impulse vector? Impulse vector would be, I can say, minus 18 I cap plus 6 j cap. So because of that final momentum I can calculate, final momentum would be initial momentum plus impulse, right? Impulse is equal to change in momentum. Yes, a lot of you guys got this right. No, Rajesh, it is A. So final momentum you will realize will be, final momentum vector would be minus 8 I cap plus 6 j cap, right? That should be very easy to see. Now, if you remember, kinetic energy is E square over 2m, right? So kinetic energy is related to the momentum, right? So from there, you will realize initial kinetic energy would be n square over 2 into mass was 2. And similarly, K final kinetic energy would also be, what is this momentum? Mod of P final. Mod of P final, you will realize is 10 only. Okay, 6 square plus 8 square root, that is 10. So final kinetic energy is also this. So therefore, what is the delta K? Delta K is 0. If delta K is 0, work done would be equal to 0. So I discussed this in today's session only. When you want to find the work done due to forces, there are two methods. Either you find the force and the displacement and you integrate for it, or you use the work energy theorem. Okay. Yes, very well done. Since the momentum does not change in magnitude, the kinetic energy magnitude remains same, and therefore the total work done by this force is in fact a 0. Congratulations to everyone who gave the correct answer. Okay. Now let's take a look at a problem which can be slightly tricky. Okay, so here is the next problem that I have for you. So here you've been told top of a large block A. So this you can see in the figure of mass 4 kg consists of a frictionless slope of height 40 centimeter. Okay, which smoothly merges into a horizontal flat portion. So smoothly merges into a small portion, and this is a frictionless surface. Okay, height is 40 centimeters. The mass of A is 4 kgs. Now you have been told that a block rests on the horizontal on the friction. The block rests on a frictionless horizontal floor. Horizontal floor is also frictionless. Now you have been told when a small block B of mass 1 kg. So let's highlight the when a small block B of mass 1 kg is released from top. So it is released from top. Whenever something is released, we assume that initially it was at rest, remember, from top of the slope. Now it slides down the slope and then stops after sliding a distance of 1 meter. It turns out it stops after sliding a distance of 1 meter. Okay, on the horizontal portion, right, of the top of the block A. Now find the coefficient of friction between the block B and the horizontal portion of top of block A. Okay. Find the coefficient of friction between block B and the horizontal portion of the top of block A. So imagine why would B stop? So after slipping down through the curved portion, it would have gained some energy, and the only reason it would finally stop is if there was friction between block B and A. Okay. So let's try and see if you can figure this out. So with all the given information, you will have to try to find out the coefficient of friction between block B and the horizontal portion of A. So horizontal portion has some friction. Okay, that is what the information is telling you. That this curved surface has no friction. This was frictionless. However, this horizontal portion has some friction. You have to find the mu. What will be the mu of the horizontal portion of A? So zero point 0.5. Okay, so zero point 0.5 is the answer that family home is saying. Right, let's see, let's see. Let's wait for some other answers. Okay. And then I'll tell you what the correct answer is. Okay, so again, this is a problem which can be complicated also if you don't know a few things. But if you know a few funded, then this is a very simple one. So depends AP, depends AP. It appears to be very tricky to start with. But if you think about it, and if you can figure it out, if you can think this problem through, then this is rather easy. It is rather easy to solve, by the way. Okay, you just have to think a bit. So this is a problem that I really like. In fact, I like these kind of problems where if you can think a little, then the problem solution becomes very easy. Friction opposes the relative motion. Yes, friction opposes the relative motion. Absolutely, family home. You are right about that. You are right about that. Okay, so tell me one thing. Zero point 0.4, yes, that may be the correct answer. So let's see, let's wait for some more answers and then we will discuss this. So family home says D and AP says C, 0 0.4. And let's see if who is correct. Let's give some time to for others also to solve this. Then we will decide. Okay. So okay, interestingly enough, try to think about the problem. Try to think about the problem. When this block descends, this block is coming down. So there is absolutely no friction, right? If I take the block and the blocks A and B as one system, because the horizontal floor was frictionless. So please remember that, yes, there it is. Horizontal floor is frictionless. So there is absolutely no friction from here also. Mu here is 0. So you realize once B reaches at the horizontal portion, B would move with some velocity. Let's call that VB. And what will happen to A? A would end up moving in this direction. Okay. A will end up moving in this direction. I hope you guys can all see that. See the total momentum. Total momentum when B was initially held at rest, it was 0. When you've released it, there is no external force in the x direction. There is a force in the y direction, which is the force of gravity. But in the x direction, the total momentum of the system can only be 0. Yes, absolutely. So also think about this. So when this comes to stop, whenever this comes to stop, how about then? When B comes to stop, since there is still no external force, so A will also come to stop. Right? I hope you can realize when this is happening. A will apply friction on B in this direction. B will in fact apply friction on A in this direction. Both will retard. Both will come to stop when this B comes to stop because the total momentum of our system is to be 0. Okay, at all times. Now you have been told that the distance that this mass slid on the horizontal portion was this. So this one, please remember this 1 meter is the displacement of B with respect to A. I hope you realize that it is not the displacement of B with respect to ground. It is not the displacement of B with respect to ground. Okay, that is where a lot of you may go wrong. So I'll tell you what you guys will do wrong, and I think family home, that is where you went wrong. Okay, so what if you don't take into account the motion of A, if you don't realize that A was also moving backward, if A was stationary. Okay, so let's solve the wrong thing first. If A was stationary, then this becomes a very simple problem, right? Then B slides and comes to rest. So and A is fixed. So then you realize B will simply come from here, get here, slide here, come to rest. So I can say that the net work done by friction would be equal to the total energy, right? Because the total energy of B is lost by the work done by the friction, right? So can I say if I take this as my initial moment when it just starts its motion and this as my final moment when it stops between 1 and 2, what I can say is that I can say that the work done by friction on B, B equal to change in delta K plus delta U of B, correct? Work done by friction, since this was 1, if A was stationary, then with respect to ground also B would have slid by 1, right? Then you could have said that this would be mu mg into 1 and this should have been equal to, okay, what would this be? This would be work done by friction would have been this and this would have been mgh. Okay, so here this mu would have been zero point 0.4. So even if you realized, even if you thought that A was stationary, then also you would have gotten zero point 0.4, right? Okay, now here is the trick. Sir, I did a calculation mistake. It's zero point 0.4. I did take the velocity with respect to A. So here is the trick. Here is the trick. Can I say that from the reference frame of A, from the reference frame of A, the work done by the friction. So do you think this is the correct answer though? Do you think this is the correct answer? Okay. Here is a problem. Here is a problem. The problem is here in this line. What is the problem? That if I go to the reference frame of A, then A would have been accelerating itself. Plus, then work done by the friction. Okay, so this is correct, but here I would have had different things, right? Okay. So how do I find this answer then? Now here is the trick. Here is the trick. That work done by friction turns out is same. Work done by friction. Uh, that is the total work done by friction on system you will have to calculate. Okay. Okay. So otherwise you will have a problem here because you did not write the work due to pseudo force. Okay. I hope you realize that. I cannot use this in the reference frame of A also. Hope you realize that I could not have used this in of A. Page note. In the reference frame of A, so forces will also do work. Why am I saying that? Because A is non-inertial, right? A is not inertial. However, to your surprise, yes, the correct answer is in fact zero point 0.4. To your surprise, the correct answer is in fact zero point 0.4. So how am I getting the right answer by doing something wrong? if I applied this, then I was getting the right answer, which is wrong. So why is that happening? The trick is if you look at the block and the wedge as one system, if we take if we take A and B as one system, then the network done by any external force is that of friction, right? Otherwise, there is no other force that is doing work. You need to remember the net work is being done by kinetic friction. Now, here is an interesting thing. Kinetic friction is an internal force, right? Kinetic friction is internal force of the system. Correct. Now, one very, very important thing you need to know is net work done on system by internal forces is independent of your reference frame. Now, this is a very, very interesting result. I hope everybody is aware of this. The total work done by internal forces on any system is always independent of your reference frame. In all the reference frame, it will be same. Okay, that is why it works. That is why it works. Now, when you calculated the work done by static friction, by kinetic friction, work done by kinetic friction in the reference frame of A, turns out it will be the same in the ground frame also. Okay. So from me, that was the trick by which I should have gone. That would have been the correct answer, the correct approach. But since this is objective, yes, you would have gotten away with the wrong approach and still got the right answer. Okay, so here I can say, therefore, net work done by kinetic friction in reference frame of A is equal to the net work done by kinetic friction in ground frame. Right? And when you are applying a work kinetic theorem in the ground frame, then yes, and in ground frame, work is done only by kinetic friction. Work done by kinetic friction would be equal to, in fact, mgh or B. Okay. So yes, that is why you, even if you solved this in the wrong manner, you would have gotten the right answer, because turns out the work done by internal forces is independent of your reference frames. In fact, that is the trick that you should have used. Either you could have done the mistake of assuming A was stationary, or you could have said I will calculate the work of kinetic friction in the reference frame of A. In the reference frame of A, whatever work the kinetic friction is doing, that will be the same that as the work done by kinetic friction in the ground frame also. So both these methods would have given you this answer. Point 4 is the correct answer, but you should know the right approach towards getting this answer. Okay, is that clear? Is that clear? This equation itself is wrong. This equation is itself is wrong. The work done by friction on B will not be equal to this, because here I should have, if I was in the reference frame of A, then I should have included the work done by pseudo forces also. That is what is wrong with this equation. But still, by mistake also, you're getting the right answer. All right, great. Let's move ahead and solve another interesting problem then. So here is another interesting problem. Here you have been told that a small block of mass small m is placed on a plank of mass capital M, which rests on a frictionless horizontal plane. So let's highlight all the keywords. Small block of mass M is placed on a plank of mass capital M, which rests on a frictionless horizontal floor. Now, the coefficient of friction between the block and the plank is mu. The block is given a sharp impulse so that it starts sliding on the plank with an initial velocity u. Now, due to the friction between the block and the plank, the block slows down and finally stops sliding on the plank. Okay, so it had an initial velocity u. Now, due to friction, the block slows down and stops sliding on the plank. The average thermal power dissipated in the process would be. So try this. What is the average thermal power dissipated in this process? So again, this is also a relatively simple one. So most of the problems of momentum chapter I found to be quite simple only. Okay, let's see if you can figure this one out. So easy to calculate. This should be easy. Okay. So what class are you in? Family home. And where are you from? So tell us something about yourself. So this is the first time I'm seeing you in my class. All the others are quite regular. So AP, Mahi, Tanya, Rajesh, Amod, they are very regular in my class. Family whom you I'm seeing for the first time. So where are you from? And what class are you in? All right, you're from Bokaro. All right. Or okay, okay. I used to have a lot of batchmates in IIT from Bokaro. I think a lot of people from Bokaro clear the JEE with very good ranks. Bokaro and Bhilai, those areas use a lot of IITians. Uh, okay, so great. Couldn't qualify JEE advanced because of chemistry. Oh, I hope you're working hard on your chemistry now. Yes, your physics seems all right. That is great. So A is the correct answer. In fact, yes. A, I think if I remember it correctly, A is the correct answer. Oh, no problem, no problem. So it's okay, it's okay. So I was also a dropper, by the way. In my first attempt, I got 4,000 something rank, and back then IITs used to have 2,500 seats only. Okay. So, but I also took one drop, worked hard, and the next attempt I got 400 something rank. So from 4,000, I managed my rank to 400. Got admission into IIT Delhi Mechanical. So don't worry. It is always possible as long as you are ready to work hard for it. All right. So a lot of people are trying, and a lot of people have already answered. So most of you are getting the right answer. Well done. This is a surprise. A lot of you getting the correct answers. So people have been studying hard then. Okay, great. So yes, so my story was that in 11th, 12th, I did not join any coaching. So I was doing self-study. So I dropped 1 year, joined a few coachings. That helped me. Actually, I had some great teachers. I had some great teachers who really helped me, take my understanding of the subjects to a different level altogether. No, Amod Kumar, B is not the correct answer. A is. Right now, I'm solving Pathfinder only for physics. All right. So you must have solved it entire Echiorma and and Irudov and all. Right. Great. So this session would be great. All right. So let's see. Let's see. What is the question saying? The question is saying, okay, so this guy was given a small impulse. This guy was given a small impulse, and it starts to slide on the plank M, and then eventually it slows, okay, and stops slipping. Can I say when it stops slipping? When it stops slipping, so initially it starts from here, See, it starts from here. This was given an impulse because of which it was moving with some velocity u. When this guy stops to slip, what will happen is that I will realize both the blocks would start moving with a common velocity. Okay, both of them would be moving with some v. That is when the smaller block would stop slipping on a capital M. All right, great. So now let's see. So can I predict the final value of v? So yes, I can. Turns out, if I take this entire thing as one system, we take m plus m as one system. There is no external force in the x direction. You will realize. Why is so? The reason for that would be that this floor was frictionless. Here mu was 0. So I can say, since the floor is frictionless, therefore there is no external force. There is no external force on m plus m system in the x direction. Right. Therefore, I can apply conservation of momentum, and therefore I can say, hence, I can say is that mu should be equal to m plus m times v. Okay. So I hope you realize that from here I can find my v, which would be mu over m plus m. So I will realize that the total energy of the system would be lost. Why? Because the kinetic friction would have done some work. Right? That is why the total energy of my system of m plus m would come down. So what has been asked of me? I have been asked average thermal power dissipated in the process. So how do you calculate average powers? You should know P average is equal to delta W over delta T. Right? So if I can find the total work and if I can find the total time, then I can find the average power, right? So finding the work is not an issue. Finding the work is not an issue at all. Do I find that? That I can find by loss of K. Delta W would be delta Ke of system. Correct? So delta Ke I can figure out. Delta W would be final energy. Final energy would be half m plus m v square minus half m u square. Agreed? Hello Siddharth Reddy, how are you? All I need to do is just substitute those values. Let's substitute those values and let's see what that gets us. Okay, I did add the page. Where did it go? Here it is. So I know delta W is going to be half m plus, and I calculated my V as, I hope you remember, my V was mu over m plus m. This whole square minus half m u square. So I'm just using the work energy theorem. All right. So good of you to join us. Now let's solve some challenging problems today. So half this and this would have gotten cancelled with one power. Okay, so one power of this would have gotten cancelled. Or maybe let's not write it like that because that might confuse you. Let's just write it as m plus m whole square. So I would have had m square u over m plus m minus half mu square. Now you realize you can take half mu square as common. Half mu square, if you take common, then you would have had u, okay, m over m plus m minus 1. So that gives you the answer as minus 1 by 2 m u square over m plus m. Correct. So I found out the work done. Okay, I hope everybody followed this. The work done I could find. Any chance of reduction in JEE syllabus? Okay, so JEE syllabus I really doubt. JEE syllabus I doubt. Maybe for mains, but not advanced. Okay, so maybe they might reduce the mains syllabus. But in advanced, see, they already do not have a lot of things. Advanced people, for instance, they do not ask you about force oscillations or anything like that. Semiconductors, they don't ask in advance. At communications, they never asked in advance. So in advance, they already keep their syllabus to the bare minimum that they want to test. So I really doubt that advanced syllabus would get reduced. Maybe main syllabus can get reduced. They can remove all those useless things, so to say. Okay, so that is what I think. Maybe the advanced syllabus will main syllabus would get reduced, but I doubt that the advanced syllabus would. Okay. Now, if I can find delta t, then I have my answer, right? What is delta t? How do I find delta t now? So that is an issue. So you will realize during the entire motion, both of these guys are applying friction to each other with the friction coefficient of mu, right? So can I say that what is the force of friction acting on this guy? This guy will feel a friction F in this direction, and this guy will feel friction F in this direction. So there are two ways in which I can find the time. Either I can solve this problem in the reference frame of capital M or in ground frame. In ground frame, I know that small m was initially moving with u, finally ends up moving with v, and it has a force of friction acting on it. So let's try and prefer communication systems and such stuff should be removed. Yes, I know. Those are ridiculous to start with. Even something like force oscillations and your damped oscillations, those kind of things should not be asked because you don't really understand the maths of it. See, they only tell you the formula. They only write this big formula and they don't tell you how you got that. Those parts should be removed. That is why, again, advanced will never ask you such things. They will never ask you anything for which you don't know the derivation. Because they like to put tweaks there, no, in the derivation part. They like to tweak the problem. If they can't tweak the problem, if you just have to learn the formula and write the answer, that is the way board likes to ask questions, right? So where uh, they expect you to just learn formulae and write the answers. They advanced doesn't. IITs do not expect that from you. IITs want you to understand your subject, not just learn it, mug it up without understanding. Just use the formula and give the answers. No. So that is why JEE Advanced will never ask you those questions. Now, as I was saying, if we focus on the block B or the mass small m, initially it was moving with U. Finally, it ends up moving with V. And the only force in the ground frame that is causing the retardation is the force of friction, which is kinetic friction. Since F is kinetic friction, I know how much that value is. F is mu times small m. Okay, so what is the retardation due to this? So retardation acceleration would be minus mu g. And I know final velocity, initial velocities are known, and I know, so I can use v equals u plus at. That will give me the time in which this comes to stop. Try and find that. I already know the value of m. The value of m again, v, sorry, was mu over m plus m. Mu over m plus m would be equal to u plus minus mu g times. Okay, so p turns out would be u, right? U over mu g times 1 minus m over m plus m. So this is mu over mu g. That is the time that I'm getting. Okay, so Vishal Singh says, sir, will the competition be higher for this year? So not necessarily in a way because let's say you may have a I think I understand why you are saying that because you think a lot of people which could not take their attempts in the previous year properly would be trying to take the exam this year again. All right. But you realize also in this year, those who were in class 12 this year, a lot of kids were not as fortunate as you guys to have been studying online, right? So a lot of people did not get the chance to study properly because of the lockdown. So I think you can think that if people from previous year are going to add to the competition, a lot of chunk from this year who will not be very well prepared would can be counted out. So the competition level, I think would roughly remain the same. Okay, think about it. In fact, the competition make it easier if you were studying constantly and if you were getting good guidance constantly. It may be easier for you because a lot of people did not have the facilities to prepare properly for this year. All right. So that is what I think. That is my personal view. I don't know what you like to believe. Okay. So I know now power average. Power average would be W over T. Work I had already calculated. How much was that? That was 1 by 2 mm u square over m plus m. I think I missed one m plus. So into 2g plus m, this and this goes. What am I left with? I'm left with mu mu g by 2. That is the average power. Okay, let's see if that was there in my options. Yes, this was option number A, which is correct. So I think a lot of you got this correct. So very, very well done. All right. So let me know if you have any confusion in the solution. So you use momentum conservation to find out the final velocity because there is no external force. Now, even if friction is acting, friction is an internal force that will never change the total momentum of the system. So we first used momentum conservation to find the final velocity. Then we used work energy theorem to find out the work done. And then we used Newton's laws to find the time. F equals ma equations to find the time. So you realize in one question you're using concepts of three topics: momentum, energy, and Newton's laws. So a lot of students end up asking me, sir, which topics are important in physics? So that is what I tell them. So if you leave out a few topics thinking, okay, this is not that important, you will suffer because one topic, one question of physics may require the knowledge of multiple topics. So you require kinematics also, by the way. You required kinematics equations also. V equals u plus at. So in one question, we have used kinematics, Newton's laws, work energy, and momentum. Right. So do not leave out anything in physics. In physics, everything is so interrelated that you will have trouble if you leave out points. If you leave out topics. Okay. All right. So go through the solution. Let me know if you have any problem or any issue, or was there any part of the solution that you did not follow. I'll give you some time to go through this. This is what we were doing. Okay. So if you followed the entire solution, you can let me know and I will move forward to the next step. Okay. All right. Clear to all? Just let me know in the chat. कुछ हाँ ना कुछ बोल दो भाई. Say something like yes, yes, we followed it. नहीं नहीं ये नहीं समझ में आया, ये फिर से समझा दो. कुछ तो बता दो भाई. Okay. All right. अचानक से सॉल्व करते करते सारे सो गए क्या? All right. So since at least there are no complaints or anything, so let's just move on to the next one. Okay. So here is the next problem. This is a very very tricky problem again. This problem I quite like. So this is going to be slightly difficult. Okay. So let's see if you can try this. So this problem tells you that a small block rests on a flat bottom on the flat bottom of a deep bowl that is placed on a horizontal floor. Okay. Now there is no friction between the block. Let's again start by highlighting all the keywords. Small block rests on the flat bottom of a deep bowl. So as you can see here, now you've been told that that is placed on a horizontal floor. There is no friction between the block and the bowl. So there is no friction between these guys as well as between the bowl and the floor. Okay, so there is no friction anywhere. The total mass, please remember, total mass of bowl and block is capital M. If if now the bowl is given a horizontal velocity by a sharp hit, only the bowl is given. Bowl is given a horizontal velocity by a sharp hit. The block rises to a maximum height h, sliding on the walls of the bowl. Okay. Block rises. Okay. Which of the following statements is correct? So is that option A, the maximum kinetic energy of the bowl is mgh? Okay, is it B, if the bowl is lighter than the block, the minimum kinetic energy of the bowl is zero? Is it option C, to predict the minimum kinetic energy of the bowl, we must know the ratio of the masses? Or is it D, to predict the maximum as well as minimum kinetic energy of the bowl, we must know the ratio of the masses? Here are your options. This, as I said, is a very tricky problem. Try this and let's see if you can find the answer of this correctly. Okay, let's see you guys give this a try. All right, try this problem. Come on, guys. This, as I said, is a very tricky problem. So this is the kind of problems that we want to solve in this session. Okay. Come on, people, try. Let's see you guys solve this. Hurry up. Let's see some answers. So who all are trying? At least let me know that you guys are trying. Okay. First, you can let me know that you are trying, and then we will see if you are doing it correctly or not. Okay, one more thing. More than one options are correct. More than one options are correct. Okay. So pay attention to that. Don't just think that if you get one right answer, then that is the answer. No, more than one options are correct in this question. So be very careful about your options. Okay. Now this is a typical Olympiad kind of a problem. All right. So let's see if you can figure this out. I don't know what happened to family home. Family home, are you still here? Hmm. I guess he has gotten disconnected because he was saying that he's solving Pathfinder these days. Okay, A and B are correct. All right. How about the other options? How about the other options? Let's see. And let's see others also try. C may also be correct. Okay. B is incorrect, but C I'm not sure. Okay, I thought you'll be more confused about B. A and C are pretty straightforward in fact. If you have found A, then you should have found C also. It's B that is tricky. Yes, A, B, C, all the three are correct. Well done. Very surprising that so many of you are getting this correct. All right. So this is a very tricky problem, by the way. Let's see if others want to give it a try. Anybody else trying? Okay, okay. So the correct answers are in fact A, B, and C. I hope you guys are solving these and not looking the answers up and letting me know here. Because this is one kind of question that I do not expect a lot of people to answer correctly. I hope everybody is genuinely trying these options and not just googling the answers and writing those here. Okay, or maybe I don't know if you have the book, looking for the answers in the book and just writing here. Okay. So anybody else who is trying, they can let me know. So I've got three answers. Anybody else trying? Should I wait for anybody else or should I just discuss the solution? All right. Okay. So Amod says B and C. Okay, so Amod, you missed option A there. You missed option A there. No problem, no problem. All right. I think enough of you have answered. Maybe we should start with the discussion of this question. All right. So today we are covering the questions very fast, right? Already covered three questions. Wow. We've already covered. Great. We are moving at a very fast pace. I think that's because most of the people are not even trying. I think, and those who are trying are solving it or and answering it very fast. Okay. I think some of you are probably even googling the answers. I have my suspicions. Okay. Anyhow. So how would you approach this problem? So let's say what this problem tells us. So this problem tells us the small block rests on the flat bottom of the deep bowl and that is placed on a horizontal floor. Okay, so there is no friction anywhere. Now this bowl is given a sharp hit and it is given some velocity. Let's imagine it was given some small velocity u. Now what would have happened? You realize the bowl would have simply moved, the block would have remained in its position. Why? Because there is absolutely no friction between the bowl and the block, right? So the bowl would have simply slipped until it reaches this portion. Here the normal reaction would have started to push this block, and then the block would have also started moving and also to rise on this. Okay, I hope everybody can realize that initially what is happening. See what is happening. Let's try and find the situation. Initially you would have seen that this would have been stationary and this would have started moving with some u. Okay, this guy would have started moving with some u and this guy would have been at rest because there was no friction. But what happens when this guy reaches the inclined part, when this thing happens? Now you realize the block will feel a normal reaction. Okay, and now this also starts to move forward as well as up. Okay, so with respect to the bowl, so let's go into the reference frame of the bowl. In the reference frame of the bowl, this would have been moving this and would start climbing up. When it climbs to the maximum height, at the maximum height, you realize what would have happened. At the maximum height, this block would have come to rest with respect to the bowl. So let's call the mass of this is m1 and mass of the ball as m2. Okay, since the total mass was given, so I'm assuming the masses of individual ball or individual items. Okay, let's assume this has a mass of m1, this has a mass of m2. Okay, and I know at the maximum height, the mass m1 should be at rest with respect to m2. Okay, I hope everybody agrees to this. At its highest position. Okay, because from the reference frame of the ball, if you see, the block would go like this, rise up and come to rest at the highest point. Okay, then it will come back. Okay, then it will come back. So since the block is at rest from the reference frame of the ball, so I can say both of them would be moving with the same speed. Okay. Okay. So what was I trying to write? At its highest, at its highest position, M1 will be at rest with respect to M2. Okay, I hope you guys see that. So let's assume that at the highest point, both of them are moving with some V. So we will assume that M1. I'll assume at its highest point, this M1 is moving with some V, and this M2 is also moving with the same speed V. That is why, with respect to one, the other is stationary. Correct. Now you realize also there is no external force on the n plus m system in the x direction. Okay, also write that. The first point that I can see is this. The second point that I can see is there is no external force. There is no external force on m1 plus m2 system in the x direction. Agreed. So therefore, the total momentum, x momentum of the system would remain conserved. For summation p in x would remain constant. So I can apply momentum conservation in x. Okay, I hope you guys followed this. That summation p external for the system in x direction will be constant. So from here what I have, therefore m. So this was what m2, right? M2 was, let's say, initially given a speed u. So m2u should be equal to m1 plus m. From momentum conservation, I'm saying this, right? So if I have assumed that the ball initially, okay, so what? Yes, I have assumed that the small block has mass m1, the ball has mass m2. The ball initially had a speed of u, and finally both the block and the ball are moving with some speed v. So momentum conservation is telling me this. Okay. Next, is there any non-conservative force? So there is absolutely no friction anywhere. So you realize the energy of the system will also be conserved. Okay. Let's add more pages. I should leave more pages for the solutions of these questions. Right? Solutions of these questions are in fact lengthy. Next, I can write also, since there are no non-conservative forces anywhere, since there are no non-conservative forces. So remember, friction everywhere was absent. Okay. Its mechanical energy should be conserved, right? I can say that. Okay. So let's call this equation number one. The equation number two that I'm going to write is going to be using this fact that total mechanical energy of the system will remain conserved. So let's write the energy conservation equation. So that would tell me what was the initial energy. Initial energy was m2 u square. So m2 is the mass of my ball. It was moving with u. This was the initial total mechanical energy plus half m1 plus m2 v square plus m1 g. This will be my equation number two. All right, so go through this and let me know you are following everything. Okay, so before I move forward, this is the question. I assume that initially the ball was given some velocity u, and finally, as it moves forward, I will realize that once the initially the mass m would have remained stationary, but as this the mass m would have appeared near the edge, it would have started to move forward and also rise up. At its maximum height, I know if I looked at the situation in the reference frame of the ball, what would have the mass done? See, let's try and also to visualize. Look at the problem in the reference frame of the ball. The reference frame of the ball, you would have seen that m1 would have started moving in this direction with u, gone up to some height, and then come to rest. At some maximum height, it would have come to rest. Correct? I hope everybody realize in the reference frame of ball. So if in the reference frame of the ball at the highest point, the mass m1 is coming to rest, so in the ground frame, both of them must be moving with the same velocity. Correct? So that is why I'm saying this. The first point I realized logically is that at the highest point, m1 and m2 both will be at rest with respect to each other. Okay, that means both are moving with the same velocity, which I've assumed to be v, which you can see here. In this situation, I've assumed that at the highest point, when m1 reaches the highest position, both m1 and m2 are moving forward with some velocity v. Now, second, I said since there is no external force on the m1 plus m2 system, so if I take the ball and the block as one system, so there is no friction anywhere. So there is no external force in the x direction. So the total momentum in the x direction should remain constant, which tells me that m2u equals m1 plus m2v. Okay, initially, ball which I have assumed to have a mass m2 was moving with u. So this was the initial momentum. So this was the initial momentum, and this is the final momentum. Both of them should be equal. That gives me the first equation. Second, I realized since there is no friction, no non-conservative force anywhere, so the total mechanical energy of the system should also be conserved. This was the initial energy, K initial. This is K final, and this is P final. K initial potential energy was zero. So I'm applying this. Now using 1 and 2, let's see what we get. In 1 and 2, let's see what we get. From 1, from equation 1, we figured that V was m2u over m1 plus m2. Agreed? I hope you guys realize that. Now I need to substitute this in the above equation. Substituting this over here, let's see what that gives me. That will give me half into u square is equal to half m1 plus m2 1 plus m2 times v square, which is m2 square u square over m1 plus m2 whole square. Plus m1gh. Correct? Okay, so this and now let's take all the u square terms on the other hand side and what we have. Now we have half 2 u square minus half 2 square over m1 plus m2 whole square. So there is a lot of calculation, by the way, in these questions. Most of these questions have slightly lengthy solutions. Don't worry about it. Correct. Now what I can do is I can take half 2u square common. If I take half m2 u square common, I have this. Correct. Now what does that tell me? If I solve this further, then I'm getting half 2 square m1 m2 over m plus m1 plus m. M1 M1 will get cancelled, and I'm getting half m2 u square equals this is m1 plus m2. That is the total mass of the system that was told to me as m. Right. So this is mgh. So this is the equation that I got after so much of hard work. That half m2 u square equals mgh. Now you realize. Let's talk about the velocities of one. What does it say? It is asking about the maximum kinetic energy. Maximum kinetic energy. So when do you think? What do you think will be the motion? What kind of motion will happen? What kind of motion will the ball and the block exhibit? Do you think will happen? Think about it. Think about it. Okay, let's go into the reference frame of the center of mass. What do you see in the reference frame of the center of mass? I mean, just think about this. What kind of motion do you think you will see? See, why I'm talking about this? Because I want to judge where the kinetic energy of the ball will be maximum and where the kinetic energy of the ball would be minimum. So that has been asked. No, I have been asked to predict the maximum and minimum kinetic energies of the ball. So what I can say is that if I draw the picture, this is what is happening, right? Now, during the entire motion, no matter how the motion happens, you realize VCM would be constant. The CM during the entire motion would remain constant, would move with a constant velocity. Okay, because there is no external force, correct? Can I say VCM would have been m2u over m, and that would have been constant. So if I went into the reference frame of the CM, okay, so please note that is why these kind of questions are very complicated. They can be still visualized from the reference frame of the CM somewhat. From ground frame, it is very difficult to even visualize what is happening. Okay, so remember, whenever you have such complex situations, try and visualize what is happening in the reference frame of the CM. Okay, so in the reference frame of the CM, this guy was stationary and VCM would be in this direction, right? So in CM frame, let's see what we see. In CM frame, I would assume CM would be stationary wherever the CM lies. Okay, now because of the symmetry, I can say that the CM would lie somewhere here. It would lie on this line only, and it would be stationary in the x direction. In the y direction, it will go up and down, fine. But in the x direction, this would be stationary. And here you realize that this guy is moving in this direction with this speed initially. I hope because this was stationary with respect to the ground and CM was moving like this. So initially you realize that this guy is moving in that direction. And obviously to keep the momentum zero, because in the CM frame, the total momentum is zero. This guy would be moving in the opposite direction. Okay. So in the reference frame of the CM, this goes here, this goes here. So what you realize is that total momentum will always be zero. So at the highest point, you would have realized that at the highest point, the situation would have been something like this. This would have been here. This block would have risen this height, and both of them would have stopped. Okay, because both of them have to stop with respect to each other. So both of them would have stopped. And then what would have happened? Then the directions would have been reversed. Okay, in the CM frame, so this moves like this. This is going here. The ball is going here. After reaching a certain height, then they would reverse the direction. Okay, so this is the kind of motion that you would have seen. I hope you can visualize this. So this is very tricky to see. I don't know if I am able to help you visualize that. I hope I am. So initially you will realize that the ball is moving like this. Now at the highest point, after this point, what will happen? That this guy from this point onwards would try to move in the opposite direction. And since in the reference frame of the CM, the total momentum has to be zero, the ball would in fact reverse its direction. That is something very, very interesting. After this point, you would have seen the ball would have reversed its direction. And sometime later, the ball would have come here, shifted here. The mass would have gone there and maybe risen to some height here. Agreed. I hope that makes sense. Okay, so let's try and visualize. Let's see that this is it. In the reference frame of the CM, this is what will happen. So this, this, this. They will be moving like this. Okay, and CM will have a constant speed. Okay, so when will the ball have maximum kinetic energy? When will the ball have the maximum kinetic energy? When it has the maximum energy moving towards right. Okay, maximum velocity moving towards right. As this guy is rising up, both the ball and the block will slow down. So in the first half, it is moving like this. In the second half, you will realize that the directions would have been reversed. In the second half, you would have seen this moving in that direction. So in ground frame, you also realize velocity of B in the ground frame would be equal to velocity of B in CM frame plus velocity of CM. Correct. And this is constant. This is constant. And how about this? This changes from right to left. So when will the velocity of the ball be maximum? When it is moving in the right hand direction with the maximum speed. Okay. Similarly, when it will be minimum, it will be minimum when it is moving in the opposite direction. Okay, so I hope you can see that. This is a very, very tricky thing to figure out. Okay, maybe not really, but yeah, some of you may find difficulty. Otherwise, if you can see that this is what the ball is doing, then and in the reference frame of CM, and CM has a constant velocity. So when it is moving like this, then it will have the maximum velocity and hence the maximum kinetic energy. When it is moving like this, then it will have the minimum velocity in the reference frame of the ground and hence the minimum K. So ball has max velocity to the right, max velocity in ground frame is u to the right. I hope you realize this. The moment this guy starts riding, it will push the ball, it will slow down the ball. So when this guy starts to rise, the ball will eventually reduce. And we discussed that also. The velocity of ball finally, you realize this velocity of ball finally was lesser than u. So during the entire ascent of this, during the entire time when this is rising, the ball will slow down. So the maximum speed that the ball will have will be u towards right. How about when it comes back? How about when it comes back? When it comes back, the ball may even go left. Okay, when it comes back in the CM frame, ball may even go left. Okay, if it is going left, then that is where it will have the minimum velocity. Okay, so I can say that ball has max velocity when it moves to the right with respect to cm, and both masses are horizontal. Okay, so this is a very very complex thing to. This is a rather long situation, and you have to think a lot. You have to think a lot. That is why I told you this is a typical Olympiad problem. This is not a problem that they will ask you in advance. This is a typical Olympiad problem where you just have to think and think and think and analyze the situation in great depth. Okay. Again, ball has minimum velocity, that is the ground frame with respect to ground, when it moves to left with respect to. Okay, so what is happening is that initially from the CM frame, this is how both are moving, and then when it is here at the flat portion, then it will be moving. Then the ball will be moving towards left with the maximum velocity, because as it rises to the right hand side now, it will also slow it down again. Okay, move to the left. When it moves to the left with respect to CM, and both masses are again horizontal. So you can let me know if you followed this. If you followed these arguments, if you followed this logic, let me know. I hope you can visualize how the motion must be happening. So it is very important to first be able to visualize what must be happening. Use some imagination, and try and visualize. If you can visualize, then trust me, it will be easy. Okay, otherwise it is difficult. Okay. Okay. I hope you were able to visualize and follow these logics. So I know for max K. Therefore, K max is this only. This is K max. Anywhere else, the ball will have a smaller kinetic energy. So maximum kinetic energy of ball is in fact mgh. Okay. So it's not the calculation part which is very long. Okay, so calculation part is a bit long, but it is more of the thinking part that is also very long. So this answer is absolutely correct. The maximum kinetic energy of the ball, which is half m2u square, because this is the initial kinetic energy of the ball, and turns out this is the maximum kinetic energy of the ball. It is equal to mgh. Now, if the ball is lighter than the block, then what happens? So first, let's okay. So to explain that, I will take a very simple case, and that will help you understand this. So let m1 equals m2. So let's imagine both of them have equal velocities, equal masses. If both of them have equal masses, then you will realize in the reference frame of the CM, both of them will always move with opposite velocities. Right? So what will happen? What will be the motion like in the reference frame of the CM? When it, or in the ground frame only, when this comes down, finally after some time when it comes down and when it reaches the horizontal thing, you realize then this is moving with some v, and this will be moving with some v dash. Okay. You will realize if both the masses were equal, then then when it comes back, V would be equal to U and this V dash would be equal to 0. Okay, think about it. Think about it. Initially, what would happen in the CM frame? Let's CM frame. If both were moving with the same velocity, then VCM would happen U by 2. VCM would happen U by 2. So you would have seen that this guy is moving here with U by 2, and this guy would have been moving here with U by 2. This CM frame. Then when it comes back, you would have seen that when these things come back, then you would have seen that the velocities would have reversed. Would have been moving here with U by 2, and this would have been moving here with by 2. Okay, in the reference frame of the CM. Okay, I hope you can see that. When it goes in this direction, it comes back in this direction. The velocities would be just same. They will just get reversed in the CM frame. Okay, so this is when it is going up. It's going up. When it has come down. And what is VCM? CM would have U by 2. Now you realize when you add these, so you will get this result. That in the ground frame, in fact, you would have had this mass M, which would have been moving with V, with U, and this guy would have come to rest. Okay. Now, if if in fact, if in fact, from here I will bring build the logic. If M1 was greater than M2, then in fact you would have seen that in ground frame, this guy would have been moving here with some V, and this guy would have ended up moving like this, some V dash, would have even reversed its direction, so that the total momentum of the system remains forward only. Okay, and it is equal to mu. So in both the cases, initially see initially the ball was moving like this, then finally it has started moving like this. So somewhere it would have come to rest. Somewhere it would have come to rest, and that is why I can say the minimum kinetic energy of the ball would be 0. So that makes this option correct. If the ball was lighter than the block, then somewhere it would have come to stop. Somewhere here it would have come to stop and then started moving in the opposite direction. And finally, yes, to predict that minimum kinetic energy. So you can see from these two examples only. From these two examples, you can see that the minimum kinetic energy is dependent on the ratio of M and M. If M1 was lesser, if M1 was lesser than M2, then you will realize that the velocities both would have always moved in the forward direction. Would have always moved in the forward direction. Then the minimum kinetic energy would not have been 0. Okay, then the minimum kinetic energy of the ball would not have been 0. So yes, the minimum kinetic energy depends on the ratio of M is to M. That is why this is also correct. Okay. I hope everybody followed this very long discussion. I think we had this discussion for 1 hour only. In past 1 hour, I've been discussing this question. Okay, because this is a typical Olympiad problem with a very complicated situation, so that is why this deserves that kind of attention. This deserves that kind of discussion. Okay, a lot of things to think about, a lot of things to figure out. This is a typical Olympiad problem. So this is an Olympiad problem. This kind of problem, because you have to think so much. This kind of problem will barely be asked in advance also. This is a typical Olympiad problem. Okay. The previous ones were apt for JEE Advanced also, which is why you could solve them so correct, so easily also. And you realize in the first I think a half an hour of this session, we were able to analyze three problems, or the first 45 minutes of the problem, the session, we were able to analyze three questions. So they took 15 minutes each, and this question alone is taking 45 minutes probably. All right, I think that is the kind of difficulty that this question poses. Anyhow, so I hope that you guys followed all the logics and are convinced with the answers. Now let's move on to an easier problem. This again is a problem which can easily be asked in advance. These kind of questions are asked in advance. So let's get back to some advanced level problems. Okay, let's give you a chance to try this. So you've been told a block of mass small m is given a velocity towards another block of mass capital M kept at rest on a frictionless horizontal floor, some distance apart from a wall as shown in the figure. Okay. Now, if all the collisions are elastic, under which of the following conditions will the blocks collide only once? This is a good question. Again, requires a lot of thought, but is not as difficult to analyze as the previous one. So this can be analyzed pretty easily. This is a advanced level problem. So why don't you guys try it? You must have solved some problems like this already. Okay, a lot of I think the institute where I was teaching before offline, we used to give this kind of problems. We used to solve these kind of problems in our classes. So this is a standard kind of problem. So let's take a look at the question one more time. A block of mass m is given a velocity towards the other block of mass capital M. So what is happening is initially you're giving this a velocity. Imagine you give this some velocity u. Okay. Now kept on a frictionless horizontal floor, so the friction anywhere is absent. Uh, 0, 0. So capital M was resting on the horizontal smooth floor. Now some distance apart, I don't know how much. If all collisions are elastic, under which of the following conditions will the blocks collide only once? So you have to find the condition for which there will be only one collision between the blocks. So imagine what are the possible cases. You just have to think about the possibilities, and if you can think about the possibilities, this should be easy to answer. Okay, so think about it, and let's see if you can figure this one out. This is one question, and I have one more question. So two more questions left. Oh, so this diagram does not belong here. I thought you could cut it. Anyhow, I hope the. Okay, so Sriram says A. No, Sriram. A is not correct. Think about it. All right, you are getting A, but A is not correct, unfortunately. A is not correct, Sriram. Unfortunately. How about others? Are others also trying? Let's see some answers. Come on, people. I know. The last discussion was so long that yeah, probably some of you went out to sleep. I guess during that discussion. Wake up, try this problem. This is an easier problem. Okay. So Sriram, just let's wait for like a couple of minutes for others to try this. Okay, and then we will discuss this. Yes, you can also try it one more time. Think about it one more time. Wait. Okay, people. Let's have some answers. Sorry. Okay, be careful about the condition that it has to collide only once. Sometimes they ask you for what condition it will collide more than once. More than once and once, there is a difference, right? So B, okay, okay. So yes, people have gotten up, I think. So I'm getting some answers as B also. Okay, all right. So far I've gotten answers of A and B. A is wrong, and all right. Let me tell you guys, congratulations. B is in fact correct. B is the correct answer. So well done, people. Very nicely done. How about others? Anybody else trying? And Shriram, could you find a mistake? Find a mistake in your solution. See. Yes, Shriram, tell me. All right, B. Yes, B is correct. Yes. Okay, a lot of people giving the correct answer. So yes, Shriram, tell me, how can I help you? Okay, sure. That is what I was actually waiting for you. Don't worry. Don't worry. You try once more, and then only I will discuss this. Okay? Don't worry. So waiting for you. Wherever you're done checking, you can let me know. Then I will discuss the solution. Okay? Because I think a lot of these guys have got this correct in any case. So I'm sure none of them are in a great hurry to for the solution to be discussed. Let's wait for you. Hmm. Yes, Mahi, that is the correct answer. Very well done. All right, great. All you guys are getting the correct answers. Very, very nice. Nicely done. Hmm. Okay, so you have found a mistake. Great. So let's think about this. This is an easy problem to analyze, by the way. Okay, this should not be too difficult. Okay, so this is the diagram that does not belong here. This is diagram for some other problem. Let's not focus on this. Let's think about the situation that has been given to us. All right, so we have been told that this is the situation, right? We have a wall. Okay, and then you have small m, you have capital M. So initially, look what is happening is initially this guy is going with a speed u. Okay. After the collision, let's imagine after the collision what will happen. After the collision, so if there are more than one collisions to happen, so let's try and find out the condition for more than one condition, for more than one collisions to happen, then I can reverse that answer. So that is what I'm going to do. So I will first try to find out the condition for more than one collisions to happen, then I will reverse it. Okay. So in what condition would there have been more than one collisions? So when they collide, for a second collision to happen, first of all, for a second collision to happen, this guy would have bounced back, then bounce back again, come back again. So if both of them move in the same direction, then you know that velocity of separation, because of velocity of separation, this guy capital M would always move faster. So there was three possibilities after the collision. After collision, there are three possibilities. Let's take a look at those possibilities. After collision, either both of them move in the same direction forward. That is one possibility. That this guy moves with some v1 and the other guy, which was chosen to be green guy moves with velocity v2. Okay, or was another possibility. Another possibility was that this guy comes to rest only. Right, this guy comes to rest, was zero, and that guy continues to move forward. Okay, v1 equals zero. What was the third possibility? Third possibility was that this guy in fact reverses its direction. This guy reverses its direction with some v1, and this guy moves with v2. Okay. Now you realize if it was this condition, then you know because of velocity of separation, v1 would be greater than v2. Sorry, v2 would be greater than v1. So obviously a second collision will not happen. Will not happen. Here also second collision cannot happen. So in these cases, the collision will happen only once. In this case, is there is a possibility of more than one collisions happening. If can I say if v1 is greater than v2, the mod of the speed of small m becomes greater than the speed of capital M, then a second collision will happen. Okay, I hope you guys can think like that. Can you guys see that the block has to reflect faster? Because if that happened, let's see what would have happened then. This would have moved with v1, this would have moved with v2, and then after this collision, after the second collision, after colliding from the wall, because all the collisions are elastic, this would have come back here with v1. This guy would have still been moving with v2, and then this guy would have eventually caught up with capital M and collided again. Okay, so that is the reason why I'm saying if v1 is greater than v2, then yes, a second collision would have happened. So all I need is that to find the condition for that. Hi Ayush, how are you? So let's try and find the condition for that. I hope everybody followed that first collision condition. The condition that a second collision would happen is that the speed, that first the block small m should reverse its direction and should move with a speed which is greater than the speed of capital M. So now it is very easy to identify. Now once I know this, from momentum conservation, I can say from E conservation, can I say that small mu should be equal to capital M2 plus small m v2 v1, right? So that is equation number one. The second equation I can write it from E. So also, since this is an elastic collision, so U would be equal to v1 plus v2. Velocity of approach would have been U. Separation का velocity कितना होगा? v1 plus v2. So that will be my equation number two. So with the help of these two, let's find the values of v1 and v2. Let us again add some pages here. Okay. So what I'm saying is, so I got mu equals 1 plus capital M v2, okay, with a minus sign because of the direction. Did I write the minus sign in the last page? No, I didn't. I have already assumed the direction to be negative, so I need to add a minus sign because it is moving in the opposite direction, right? And I also know u equals v1 plus v2. So from here, I can substitute the values and find v1 and v2 in terms of u. Okay, so let's do that. These are my two equations. Let's solve to find v1 and v2. So here I can say that 2 minus 1 substitute minus v1, and let's substitute this value, take it and put it here. Then I will get mu equals minus m v1 plus equal to m times 2 minus v. So what am I getting? I am getting m plus m v1 equals there I'm getting m minus m. So I got v1 as m minus m over m plus m, right? How about v2? v2 would be q minus this. Q can be taken common, and then I will have, I think, 2m over m plus m. Correct. Now, condition for second collision. Condition for second collision was v1 should be greater than v2. So I can say therefore m minus m over m plus m times q should be greater than 2mu over m plus m. This and this gets cancelled, u and u get cancelled. And what I'm getting is m greater than 3m. So if capital M is greater than 3m, then yes, more than one collisions will happen. So if I don't want that, I should just reverse that. Okay. So therefore, for blocks to collide only once, it will be the other way around. This option would be correct. In this condition, in fact, I cannot even have the equal to sign. Okay. Did you guys follow this? Let me know if you followed this solution. This is a typical advanced level problem. This can be asked in advance. Okay. Is the solution clear? So we found the condition for the second collision, and then we just reversed it. Okay, great, great, great. So let's move on to the last question. This is another tricky question, slightly tricky question. Okay, and this is the last question that we will discuss today, and then I will wrap up today's session. Okay. So this question says that a particle projected at an angle theta with the horizontal from the center of the floor in a cylindrical room of radius r returns to the point of projection after three elastic collisions with the walls and the ceiling. Okay, that is what is happening. If the particle remains in air for time t, then the speed of projection. So there are four options. Again, this is also a very tricky problem. So I don't know. I don't know. This can be asked in advance, but this feels more like an Olympiad kind of problem. You'll have to think about this one. Wait. So let's see. Let's see you guys try. I think this problem can be asked in both advance and Olympiad both. Right. Both of them can ask this kind of problem. Advance maybe slightly less likely because this is tricky. You have to think a lot in. Okay, no, Shriram, that was not your internet. It was my internet. In fact, I got disconnected, which I didn't even realize. Okay, I didn't even realize that I had gotten disconnected. Okay, so let's try this and let's just quickly do this. All right, so now it is back. I didn't even realize I was talking. I was telling you that I'll give you more than 2 minutes. Don't worry. Okay, and then only I will discuss the solution. Okay. Yes. Now it is good because it was the problem was at my end. Okay, I had lost the net. Now it is fine. So try this quickly and let's see if you can find the correct answer for this. Okay. All right. So this is the last problem in any case. So let's just discuss this and wrap up the session. Okay. All right. Let's see if you can answer this. Okay. So I am getting some answers. So Mahi G says B and AP says D. Hmm. Okay. Okay. Let me tell you something. There are more than one correct in this question. More than one correct options are correct. So you realize if two options are correct, then one has to be either of A, B, C, and the other has to be D. Okay. So more than one options are correct. Okay. Yes. So I think interestingly, all you guys are right. All you guys are right. The correct answers are actually B and D. B and D both are correct. Okay, so very well done. Yes, absolutely. Great. A lot of you guys got this right. Wow. Okay, how about Sriram? Sriram, could you figure out the answer? So this appears very complex, is very tricky, but if you think about it a bit, trust me, the solution is very simple. The solution is very simple if you can just think a little bit about it. Okay, there is in fact hardly any maths involved in the solution. Okay, there is, but very less. Okay, it's just a tricky question. So I think again, either these guys have figured things out or they have Googled the answers. Because so many people giving all the answers correct is very unlikely. Usually doesn't happen. I don't know. Well done, guys, in any case. Greater than or equal to root of. Okay. Okay. So not equal to will not happen. Equal to will not happen. It will be greater than only. It will be greater than only. Okay. Okay, so let's first try and understand the situation. So should I discuss the solution, Sriram, or do you want to give it some more try? Equal to will not be there. So let me know if you want to take some more time or should I discuss the solution? Give for homework. Okay. Okay. So all right. Then you will have to wait for an entire week for the answer solution of this. Okay. All right. So since you insist, so that is what I will do. All right. So consider this as your homework problem. This as your homework problem. You can try this. I've told you the answers. The correct answers are B and D both. So try and figure this out, and we will discuss the solution of this problem in the next class. That is next week that we meet. Okay. So that was it. That was all the questions that I had planned for today's session. I think yes, we have finished the time of the session. Also, it's been 2 hours, so we had planned. I had actually planned a 2 hour session only. So this is time for me to leave. But before I leave, let me remind you that you should be getting your Unacademy subscriptions if you haven't gotten them already. And this is how you do it. You go to the plus section of the app, you select your goal as IITJ, and you click on that get subscription button. Okay. Once you are redirected to the payment page, you can use the code RDLive to get a 10% off on all these subscription fees, which are already very moderately priced compared to the fees that you guys pay at your offline coaching setup. All right. And you will realize when you click on proceed to pay, all the subscriptions which are of 6 months and above have the no cost EMI option available. So you can convert this payment into any number of EMIs, which will definitely reduce the burden of this payment. So if you can afford this, if you can, I think you should be able to, because the prices are not much for this subscription. You should be definitely getting the Unacademy subscription. It will definitely boost your JEE preparation. Even if you're already studying from somewhere, trust me, there are a lot of things, new things that you will learn here, as you probably do in my sessions. I hope I help you learn new things which you won't probably find even in the usual places that you're studying. Again, if you want a more personalized care, if you want more personalized guidance, then Unacademy Iconic subscription is the way for you. You go for the Iconic subscription, and this will take your JEE preparation to the next level, where you will get a personal coach, you will have ITJ workshops for guidelines, study planner, and test analysis sessions. Now the fees of the Iconic subscription is going to go up from 30th of November, so pay attention. So this subscription is going to get more expensive from 30th of November. Okay, and these are the new prices, by the way. So currently, the 6 month this is what the price of 6 month subscription will be after 30th of November. 6 month subscription would cost you 38,000. 12 month subscription would cost you 65,000. 4 month subscription will cost you 1 lakh rupees. Okay. Even at that cost, you realize personal guidance would cost you 4,000 rupees, when in fact people pay way more than this for their personal tuitions in class fifth and sixth. Okay. So again, if you want to go for the Iconic subscription, if you want personalized guidance, then now is the time before 30th, before the prices get hiked. Okay. Also, on the 2nd of December, we are going to have an Ask Me Anything session, where this will be a fun interactive session where you will interact with the entire team of JEE English, where you can ask us anything, whether it might be related to studies, it may be related to other things. We can have all sorts of discussions. Okay, here. So make sure you're connected with us so that you get to know your teachers better, and we guys have some fun in interacting with you guys. All right. Again, if you like today's video, don't forget to press the like button and share it with as many people as you can. So we are not only discussing your JEE level problems, JEE advanced level problems, even Olympiad level problems, everything completely for free, courtesy Unacademy. So make sure those of you who can't afford the subscription should be getting taking advantage of this free content that Unacademy is providing you. So don't forget to press the like button to encourage. That gives us the encouragement, the teachers and the team, a lot of encouragement. We because that is the only motivation that we have, here on this platform, teaching here, the interaction and love that you guys show. All right, so make sure you express that love by hitting that like button, and also share it with more and more students, so that everybody can uh, take advantage of this high quality content being given to you by Unacademy for free. Don't forget to press the bell icon for receiving notifications of all future sessions and the PDF. Okay, so I don't really think you need the PDF of this session much. Okay. All right. Those of you following us on the JEE English channel of YouTube should be connecting with us on the Telegram app using this link. So when you get there, when you join us, connect with us on the Telegram app, you will get regular notifications of all the sessions and amazing lectures happening on the JEE English channel of YouTube. You will not miss out on any of the sessions. Again, before I leave you, this is my code RD Live. So if you like my lectures, if you want me to be your guide through your IIT or your Olympiad journey or your KVPY, any kind of competition that you're preparing, or just for the love of physics, if you want to have discussions with me, then you can get yourselves the Unacademy subscription, enroll in my courses, and you will enjoy a 10% off if you use this code RD Live. So that's it from my side. Yes, Sriram, tell me, how can I help you? Tell me, Sriram. So I was just about to sign off. Tell me. What is it that I can help you with? If you could just hurry up. Yes, tell me, I'm waiting. I am waiting, I'm listening. Okay. I am waiting for you. Don't worry. So tell me. Tell me, is there any way I can help you? Anything that you wanted to say or ask? Just hurry up because I have to end this stream. Can I get your WhatsApp number? Okay. So no, that is not allowed. I'm so sorry. So you can come on the J English channel, attend my lectures. You can interact. You can ask me anything that you want here. So we are not allowed to share our personal numbers on public platforms, especially. Okay. So I'm so sorry for that. Hmm. But don't worry, you can come here to the J English channel and you can come to my lectures and ask me anything here only. All right. You can also download the Unacademy app. Follow my lectures there. There are a lot of free lectures also available, so you can join my free sessions also. Okay, so I don't know about that. I think that used to happen earlier, and that is why we were advised that I think that is not allowed. The company doesn't allow it. Okay, so we are supposed to interact with you through company platforms only, official platforms only. Okay, we are not to interact with you on a personal basis. I'm sorry. I think people could be doing that earlier, but now it's not allowed. Okay, and maybe maybe some people don't bother about the rules, but I do. Okay, so don't worry, don't worry. Any kind of help that you want, I will help you here in these sessions. You can also download the Unacademy app, join my free sessions. Okay, join my free sessions and ask any kind of doubt there also in my free sessions on Unacademy app. Okay, I'll try to help you to my best here only. Okay, don't worry about it. All right, with that, I will take your leave. So you guys keep practicing, keep studying hard, and I will see you next Saturday with this session again. All right, so take care and good night.